All right, welcome back to Database History. Today we are doing a real deep dive. We're going to decode the tech stack that completely transformed the FBI. I mean, we're talking about a shift from an agency that just stored data to one that actually computes identity.
Yeah, that one sentence says it all, doesn't it? It perfectly captures this huge paradigm shift. Think about it. We've gone from, dusty file cabinets and old-school databases to this active computational system that can literally build a picture of a person from all these different digital signals.
And these four systems, they're basically the four pillars of that whole computation engine. Now, each one is a massive system all by itself. But what's really revolutionary is how they all work together, all powered by modern AI. So let's dive in, and we're going to start with a biometric core.
Okay, so right at the center of everything, you've got NGI. That stands for Next Generation Identification. And I want to be clear, this is not just some digital Rolodex. No way. It's the biometric heart of the entire infrastructure. It's the very foundation that all modern identity records are built on.
And the scale we're talking about here, it's just staggering. I mean, NGI holds over 100 million fingerprint records and tens of millions of facial images. But here's the crucial part. The real key isn't just storing all that data. It's about conversion. Every single physical trait gets translated into a unique mathematical format. So you have minutiae templates for fingerprints, phase-based codes for irises, and for faces, well, that's where we get into what are called deep learning embeddings.
So, how does that even work, right? How does a system take a regular photograph and turn it into something a computer can search against millions of others in just seconds? This is where we get to the real core of the AI.
All right, this really breaks it down for us. It's basically a three-step pipeline. First, the system takes the face and it aligns and normalizes it, to fix any tilt or weird lighting. Then, it gets fed into what's called a convolutional neural network, or a CNN. A lot of times, this is based on something like a ResNet architecture. Now, this network chews on the image through a bunch of layers, and what comes out the other end isn't a picture. It's a 512-dimensional vector.
And this embedding vector, this is the whole key. The best way to think about it is like a super detailed numerical fingerprint of that specific face. The geometry of the face is now just a single point in this massive 512-dimensional space. And what's so critical is that faces that look really similar will have vectors that are mathematically super close to each other.
This whole vector approach is a complete game changer compared to the old way of doing things, which was just pixel matching. That old method was slow, and it was so easy to fool with bad lighting or different angles. But vector search, it's totally different. It's not comparing the pictures themselves, it's comparing their underlying mathematical signatures. It searches by what is like, not what looks like. And that is such a critical distinction. It makes it way faster and so much more robust.
Okay, but wait. Searching millions or even tens of millions of vectors still sounds like it would take forever, right? Well, this is where these clever algorithms called approximate nearest neighbor, or ANN, come into play. By using some really advanced data structures like HNSW graphs, the system doesn't have to check every single vector. It intelligently jumps through the vector space to find the most likely matches almost instantly. It's actually the same kind of tech that powers all the modern vector databases you hear about today.
So that's the magic behind how the system processes faces. But obviously, investigations rely on way more than just that. So the question becomes, how does the same core AI principle, this idea of embeddings, apply to all that messy, unstructured data like an officer's report or hours of surveillance video?
Well, it turns out that the same fundamental concept, this idea of turning complex data into searchable embeddings, is used for all sorts of other information. And when you do that, you unlock completely new kinds of insights.
Let's take video, for example. You've got CNN-based models that can detect people and objects in footage. That's cool. But the real breakthrough is something called person re-identification. This is where the system creates embeddings not just for a face, but for a person's whole body shape, their clothes, even the way they walk. And what that means is you can actually track a person across a bunch of different cameras, even if you never get a single clean shot of their face.
And this whole idea extends to text, too, with a system called NDX, the National Data Exchange. The best way to picture it is as this massive, sprawling graph that connects instant reports, arrest data, and interview notes from all over the country. It actually uses transformer-based AI, the same kind of tech behind things like ChatGPT, to read all of that unstructured text and automatically figure out how to link people, places, and events together.
And here's the result of all that, which is implemented in their Sentinel case management system. You get semantic search.
So an investigator isn't just typing in keywords anymore. They're searching for meaning. The system can actually understand the concept behind what they're asking and find the right documents, even if those documents use completely different words.
So, okay, we've got all these incredible AI capabilities, but what's holding it all up? What's the foundational layer that lets all of this run at a massive national scale? And maybe more importantly, where is all this tech going next?
Well, the answer to the first question is the CJIS Cloud. This is the super secure, high-compliance infrastructure that provides all the raw horsepower. It's what delivers the scalable compute power for all that biometric matching, the encrypted storage for all the sensitive records, and it runs all the containerized services so this can be deployed nationwide. You can really think of it as the engine room for the entire stack.
And all of this, it's pointing towards the future, which is something called multimodal identity. The big idea here is to create a single unified vector space where you can combine embeddings from everything, fingerprints, faces, iris scans, text from case files, and search it all together. The goal isn't just to build a better database, it's to create what they call a fusion engine, a system that can truly understand what identity means across all these different types of data.
Which, of course, leaves us with a pretty final and profound question. When every single component of a person's record, from their physical features to their documented history, is converted into just a mathematical representation, a single point in some high-dimensional space, what does identity itself even become?